ray diagrams and magnification. I'm going to go over a bunch of more terms. I know there's lots of stuff drawn. I will go over it so you know what I did, okay? Okay, so ray diagrams and magnification. First of all, I set this all up with my pen and pencil thing with my large paper clip. Nope, I did it with my small paper clip, sorry. Okay, so I set that up with this curvature. Not that it matters too much, it's just so that you know what I'm talking about. So I'm going to talk about sign convention and variables. All right, so this is my mirror. It happens to be a concave mirror. Your textbook doesn't talk about the vertex, but in my physics textbooks, they were referred to it as the vertex. So here's the principal axis. I've drawn in my mirror. This is the center of curvature, and here's my focal point. Now, what I want to do is I just want to talk about hi-ho and dido. What are those? Well, here is my object. Often in physics, we just use arrows because we're not worried about details. We're worried about just finding out where the image is relative to the object. So here is an arrow placed at some distance from the mirror, or in physics textbooks, it'll say vertex. So if I measure the height of the object, that's what HO stands for. You measure up from the principal axis. Okay, it's approximately 1.5 centimeters. 1.5. All right, now to measure distances, we always measure along the principal axis from the vertex, not from the center, not from the focal point, from the vertex of the mirror. Okay, so this would be 9.15 centimeters. All right, I know we usually measure things in meters in physics, but the scale of this is all small. And when you look at the equation that we work with, it really doesn't matter what your units are. It just matters that they're all the same units. All right, now we'll be learning some ray rules, but I'm going to worry about that for another video. Like I said, there's so many things to learn and lots of new terms. So remember how I said if you have a ray that is parallel to the principal axis, it actually gets reflected through the focal point, or appears to go through the focal point if you're doing the other type of mirror. All right. So what we need is at a minimum, we need 2 rays, all right? And where they cross is going to tell us where they're coming from. Like if I take 2 rays, so I'm going to take 2 rays, I've done 1, it's coming from the top, so it's going to produce the image of the top. All right, so if I take my second one, like I said, we're going to worry about the ray rules after, just follow what I'm doing. All right, and you're going to take this and you're going to draw a line through the center. It's going to go directly there, and it's actually going to bounce directly back. So you'll see 2 arrows there because that's an incidence of 0, so it's just going to go straight and back. Now, where those 2 cross form the tip of my image, because they came from the tip of the object. They're going to produce the tip of the image. Now, you can see here, maybe I will zoom in just so you can see. Okay, this is my image. It's a very small arrow. We'll do other ones, all right? And that you can see is upside down. You're like, well, how do I know that? If they came from the top, they form the top of the image. And since the bottom was here on the principal axis, the only ray that works is the one that goes along the principal axis. And if you go straight up to the principal axis or down, that's going to be your image. So you can see it's very, very short, and you'll see it's below the principal axis. So we measure down from the principal axis. You can think of the axis just like your 0 axis in math. So I've mentioned a whole bunch of things. Let's talk about the things that are new. Okay, so height of the object, height of the image. Okay, distance to the object measured from the vertex. I have it there. Distance to the image is also measured from the vertex. We'd measure it there. Oh yeah, I have DI right there. Okay, so those are some things you'll have to recognize. Also, I think it makes sense. H stands for height, O stands for object. The subscript indicates what we're talking about, and the symbol indicates the type of measurement. All right, so now, like I said, all measurements need to be in the same units. So if you want to do it in meters or millimeters, go ahead. Now, part of this note too, we need to talk about sign convention. And when I'm talking about sign convention, I'm talking about positives and negatives where we, positive and negatives where we use them and why we use them. All right, so I'll just slide up to that part of the note. And what we have is signs. So all measurements up from the principal axis are positive. All measurements down from the principal axis are negative. You can think of it again like the 0 axis, x-axis, and up is positive, down is negative. Now, this is where it gets a little bit tricky. You need to understand the difference between real and virtual. And still, I don't know how to spell. Okay, so measurements to real objects are positive. Measurements to virtual objects or images are negative. Okay, so if it's virtual, it's a negative. If it is real, it's a positive measurement. So it actually doesn't really matter necessarily what direction you're measuring to, but it matters the type of object or image that you're measuring to. Now, we often talk about magnification. If I say it's 2 times, if someone was saying the magnification is 2 times, you'd know that the image is 2 times larger. So with these variables, hi, ho, and di, do, we can calculate the magnification that a mirror or a lens produces. I know right now we're on mirrors, but technically this works for lenses as well. So magnification is a ratio that tells us the size of the image compared to the object, and we can calculate it. So big M, okay, it's an uppercase M, stands for magnification, and it can equal a ratio of actually the distances as well, but you'll see a negative there, okay? That negative is not a mistake. It's missing out of your textbook, okay? So it's negative di over do. So if you have the distance to the image or the distance to the object, you can calculate the magnification. You can also calculate the magnification, which I think is more obvious, if you have the height of the image and the height of the object. So again, it's a ratio. All right. Now, the neat thing is since these are both equal to m, these can also equal each other. So why is this useful? Well, this is useful because what we'll be doing is asking questions about the object or the image relative to one another. So let's say in a question, you are given the distance to the image, you are given the height of the image, and you are given the height of the object. I might say, well, where will I find the object? Where meaning distance. So that means if you have 3 of those variables, you can find the other one. You don't always have to know the magnification as long as you have all those variables. All right. Now there are some practice questions with magnification. I'm hoping you can do this. I know I didn't do an example. I probably can do it if you want, but I tend to want to keep these videos shorter rather than longer. But you know what? Maybe we can use this one up here just to prove to you that this is correct. Now, although it's not a great job, because I don't know if I did these really well. And what I mean by really well, I mean you make sure that your lines are all parallel and whatnot to the principal axis. And using thinner pens and pencils make it better because with it being thick, you know, your measurements can vary. So just to show you that this works, why don't we do it? So I have the distance to my object. I'm going to write this on another piece. I'll write it here. So the distance is on here. Distance to my object is equal to 9.15 centimeters. Okay. The height of my object is 1.5 centimeters. Okay, now it's easier for me to measure distance of my image, so I'm going to measure the distance of my image, and then I'm going to calculate HI and prove that it probably should be, you know, a couple millimeters. So let's go ahead and do this. distance to my image is 1.6. Distance to my image is 1.6 centimeters. Now, that is a real measurement because these rays actually do cross. If these were dotted lines, then that distance would be a negative value. So, what we'll do is I'll just take a separate piece of paper here, and I'm going to use my equation, and I'm going to see what that height should be. It should come out to be negative, and it should approximately come out to be a couple millimeters, maybe 3. Okay, I don't want to put my head over there and hit my phone. So let's see. Okay, and then we can also calculate magnification. Why don't we do both? So it's hi, ho equals negative di over dou. Now, if you're not good at rearranging equations, that's something that you need to work on. I can tell you what I do. So what I want to do is I want to solve for height of my image, which actually is already on the numerator. So I can leave this equation. Let's say I wanted to solve for ho. We could actually flip this equation over. You can do ho over hi equals negative dou over di. Okay? It actually really doesn't matter because if you inverse both, they're the same. Okay? So, and again, you can put left or right. That equal sign doesn't matter. All right. So now, how do I get rid of the ho here? I multiply because it is dividing. The opposite of dividing is multiplying. So that means I want to multiply by ho on both sides. All right? So that and that divide out. I don't say cancel. They divide out and become 1. And on this side, we are left with the 3 variables we have. Now, it doesn't matter where you put the negative. Okay, and multiplication and division with bedmass don't really matter which order we do it in. So let's put in our numbers. I'm going to sub them in. DI, 1.6 centimeters. HO, 1.5 centimeters. And DO, oops, I wrote DO. That's not what I want to write. 9.15 centimeters. Now I put in the units because that's what I do. Whoops. Okay. And you can see that the centimeters and centimeters will divide out and the units we're left with are centimeters. And this is where I'm saying it doesn't really matter the units, but you really have to pay attention so you know what the units will be in the end. Okay? So there's a negative there, but I'm just going to go 1.6 times 1.5. I hit equals and then divide by 9.15. And that gives me, there's the negative sign. I didn't put the negative in my equation because I just know that a negative times positive or divided is going to end up being negative. That's 0.26 centimeters. That's pretty close to 3 millimeters. And if I went up here and looked, if I zoom in, maybe I can get in there and go, that's not bad. Now don't forget make sure I'm measuring from the right line. Should be measuring from the blue line. Okay? And like I said, my marker kind of bled in there. It's not bad. It's a couple millimeters. 1, 2, 3 and a bit, but that arrow ended up being kind of fat. I can see it actually goes past where my lines cross. Not bad, Gorak. All right, and you guys can do the same. So if I asked for the magnification, think about this. Is the magnification going to be greater or smaller? Well, the image is a fraction of the object, so it should be less than 0. So let's talk about what this magnification is, and we can actually calculate it. Magnification, right, is with the numbers that I was given. I have DI and DO, so let's use that, because then I'm not using a calculated value. So negative di, the negative's out there, it's 1.6 centimeters. So the negative is in the equation. And I have to divide by dou. And you can see with magnification that you are not going to have any units. We just say it's times. So I'm going to take my 1.6, I'm going to divide by 9.15. I get negative 0.17 times. So what this means, and I'm just going to approximate this to 0.8, 2 times, okay? Which means it is smaller and it's inverted. So this is smaller, and this means inverted, or another word for inverted, sorry, the fraction means smaller, and this negative sign means it's inverted or flipped. So magnification can tell you different things. If it's 0 magnification, or 1, because 0 is not going to make sense, you can't really get that. If magnification is 1, that means that there's no sign change. If it's positive, it means it's the same size and upright. If magnification was -1, it means it's the same size and it's flipped. If magnification was equal to -3 times, then that means it's 3 times larger. The image is 3 times larger and it's flipped. So there's a little bit of magnification, and you can try those practice questions in the textbook that I posted.